Good afternoon, everybody. Now we can start with the presentation about the new CO2 heat pump from Enerbu company. Only to introduce our company very briefly. This is our history, starting in 2007 with the first heat pump produced, and with several milestones during our history, including the updating of the heat pump range over the years and introduction in 2012 of the heat pump with CO2 refrigerant. With following after this data, several updating with natural refrigerant like propane and other low GWP refrigerant. In the late years, we have also new improvement for our range, and we are thinking about new products always with new refrigerant, natural refrigerant, and low GWP refrigerant for the future. Our product portfolio include, at the moment, solution for high temperature water production with synthetic refrigerants, and a complete portfolio with natural refrigerant solution with propane and with CO2 used as a refrigerant. One of our straight points is the climatic chamber. We are able to test all the units we produce, all the units in our catalog, in our climatic chamber, testing all the points around the working limits. And in this way, we are able to satisfy all the customer needs in terms of reliability and performance confirmation. So for this reason, we develop this new feature for our factory, including the possibility to develop new units and to test new components. After this, we have also a complete training program for after-sales purposes, but also for pre-sales and for sales activities. This is one of our strength points, also because we can customize the trainings according to our customer needs. In this way, we can be closer with customers and to the market and be more effective on our products. Only a very quick overview about CO2 used as a refrigerant. You perfectly know CO2, I think. This is the recognized greenhouse gases right now, but using it like a refrigerant fluid, we can avoid to increase the CO2 equivalent released in the atmosphere, so we can reduce the greenhouse effect. Combined also with the high efficiency on our units, we can have a very good impact to protect the environment. Brief history for refrigerants. Now, starting from the first generation, we arrived to the fourth generation. So refrigerant with zero ODP, very low GWP, and short atmospheric life. But even if there are these refrigerants, chemical refrigerants, the CO2 as a refrigerant, that is one of the first generation refrigerant, is still a good choice for heating and also for cooling application. Advantage of CO2 for the heat pumps. We can easily reach in our unit 90-degree living water temperature, even if we are working with the outdoor ambient temperature of -20. In all the unit envelope, we can grant the higher COP possible, and at the same way, we have zero ODP refrigerant and 1 GWP refrigerant. So in this case, we are speaking about units that are excluded from F-gas regulation, so there are no several restrictions. We can reduce the CO2 emissions, direct and indirect emissions, and of course, we can propose this unit for substitution for a system with compressed natural gas. Only one short introduction. We are now working to change the range name. So up today, you will find in our booth the HP90 documents and description. But in the future, in our catalog, we will have the same unit with the name Gold. This changement is a new approach for us because we decided to grow as a company and to show how our product are reliable and how high is our quality. So we decided to switch in a different way the naming. Only to give you an overview about the air-to-water version of this unit. So we have 6 models with a heating capacity from 14 kilowatts up to 140 almost. Application is mainly for commercial and industrial application where high temperature water is required for the application. These 90-degree living water temperature are always granted, even if the outdoor ambient temperature is down to -20. There is the base version, the air-to-water version, and it is possible also to have a water-to-water version with more or less the same heating capacity. So we have this air-to-water range, 6 sides, 2 versions. It is possible to have the base version and the low noise version, and the A+ class for domestic hot water production. So for this unit, we have this kind of classification for the ERP regulation. About the range, this heat pump, of course, uses CO2 as a refrigerant. In general, the base unit is only for heating-only purposes, but it is possible to have an option in order to produce cold water while the unit is producing also hot water for the users. Main advantages and characteristics. As I said to you, up to 90 Celsius living water temperature. Delta T in this case must be higher than 30 degrees. The hot water inlet temperature maximum is 30 degrees, but we have also an optional kit that allows the unit to work with entering water temperature up to 50 degrees. In any case, for all year round, we can grant high COP for hot water production. And for this specific unit, higher is delta T, higher will be the COP for the heating purposes. Always an overview, we have the main feature for the range. So all the unit has one refrigerant circuit. We already saw the characteristics for this unit. Compressor are pistons reciprocating compressor. There is always installed a variable speed circulation pump. The heat exchanger is a brazed plate type, and we always have axial fan with cut phase regulation. Of course, the electronic control is included, and the working limits are very, very wide. The main option for these units are the low noise version, the HIT kit we spoke before, in order to increase the allowable entering water temperature. There is the possibility to manage by the unit the anti-Legionella cycle management. There is the cold heat recovery, as we spoke before. There is the circulation pump for the cold heat recovery available as an option. There is the possibility to manage the secondary pump on the circuit. There are also the antifreeze heaters for hydraulic circuit, the EC fans for the unit, the possibility to have communication with external BMS or general controller with Modbus or BACnet. It is possible also to have a cascade application up to 6 units. So it's quite easy to satisfy system with more than 1 megawatt of heating capacity required. Anti-vibration mounts and of course protection for coils. So all these parts are option or kit that we can add on the unit. For the refrigerant circuit, I want to go in very, very deeper details on this circuit. I put this slide only to show you that the unit is very, very simple. There are no so many pipes, so many components. The principle is very easy. Components are common in the market. So even for the manufactured, but also during the life of the unit, is very, very easy to keep the unit working in a right way and to find out, if needed, every replacement part on the market. Concerning the working principle, here we have the standard unit, air-to-water. So for sure, it is an electric heat pump, so there is the input power from the network. This unit, in this case, is sized to produce 80 degrees living water temperature with 20 degrees at the inlet. And of course, the source fluid in this case is air. And with this condition, we are producing more or less 88 kilowatt in heating. And to the source, we are using 61 kilowatt from outdoor air. Okay. With this condition, we can have a COP of 3.21 with 80 degree living water temperature. So this is the demonstration that these units in standard condition can reach very, very high COP. And for domestic hot water production, it could be very, very interesting to propose this kind of unit with high energy efficiency. We spoke before about the cold recovery option. You can easily see, compared to the air-to-water unit, we have an additional heat exchanger in parallel with the coil on the source side. And we can decide, using an external input, to use this exchanger to cool down unit for the system. So also in this case, the circuit is extremely simple, and also the components are very, very simple. But in this case, we can use the unit to produce simultaneously hot water for domestic hot water purposes, for example, and cold water for the space cooling. This is one of the applications. Or, for example, if you want to use this kind of solution for an industrial system, we can use the hot water for some industrial application, like, for example, cheese production, and the cold water produced on the recovery to cool down the milk inside the storage tank. So you can use completely the input power in the better way. This is the working principle in this case. So we are working like before with 20 inlet water temperature from the users and 80 outlet water temperature to the users, so more or less 91 kilowatt. The input power is more or less the same. In this case, fans are off, and we are working with the cool recovery, producing 7 degrees water with a capacity more or less of 65 kilowatt. In this way, we have a COP of 3.52 for heating, but the total energy efficiency ratio for the unit is about 6.03. It means that with 1 kilowatt of electric supply, we can produce more than 6 kilowatt in heating and cooling. And this could be very interesting for some specific application. To give you an overview about the technical data, these are our sides, so from 18 up to 150. And you can see, working with outlet water temperature 80, we have always COP higher than 3. For the heating pure cooling version, the COP or the TER will be always higher than 6. So in terms of energy efficiency, both solutions are very, very good. And dimensions are quite small. We have a small footprint, and this unit could be installed in an easy way, more or less everywhere. In terms of working limits for heating application, you can see we have external air temperature on the lower part of the chart and water temperature on the left part. So you can easily see we can work from minus 20 ambient temperature up to 45. And in all these conditions, we can produce water up to 90 degrees. So unit is perfectly able to satisfy all the requirements for the domestic hot water production or industrial heating production. For the version with the additional cold water recovery, These are the working limits. So on the lower part, we have source water outlet temperature. So from the cold water recovery, we can have a living water temperature from more or less 18 down to minus 10, while in any case, we can have 90-degree living water temperature. So for this unit, we have a very, very large working limits possible. The water-to-water version, in this case, the sides are more or less the same, but we have a water-to-water unit. So 6 sides. In this case, all the units are already in low noise version. And for all units, for domestic hot water application, we have a A+ class. So the range, also in this case, is heating only working mode. The main characteristics and advantages are more or less the same. So very high living water temperature, about 90 degrees. Delta T always bigger than 30 degrees. Hot water linear temperature maximum 30 degrees. But also in this case, we can have the HIT option that allows to work with inlet water temperature up to 55 degrees. In terms of features, also in this case, we have the circulation pump variable speed already on board. Also in this case, all the units are one refrigerant circuit with a reciprocating pistons compressor and plate heat exchanger. Controller and the operating limits are more or less the same we saw for the cool recovery version. And the low noise version is always included on the water-to-water units. Main option also for this, we have HIT kit for high entry water temperature up to 50, the anti-Legionella cycle management, secondary side pump management, the anti-freeze heaters for the hydraulic circuit, Modbus and backnet communication connection, cascade application up to 6 units, and the anti-vibration mounts. For this unit, we have more or less the same schematic we saw for the air-to-water, but at the end, it is probably a little bit more simple compared to the air-to-water because we have, instead of the coil and the fan, another heat exchanger on the source side. So, as I said before, we keep it simple in order to have a reliable product and to be able to find out always spare parts or something like this. So something very, very simple. As a working principle, we saw before, we have a water-to-water unit, so the input power is more or less 13 kilowatt. On the source side, we are working with 10-20 inlet water temperature and 80 living water temperature with a heating capacity more or less of 50 kilowatt, while on the source side we are working with 12.7, okay, so standard working temperature, with more or less with a lower, let me say, source, little bit lower source capacity. In this case, the COP is 3.77, so it's a very, very good like efficiency, and we can use this unit for replacement of gas boiler and so on. In terms of technical data, more or less we have the same of the air-to-water for range extension and a little bit higher COP. Working limits is the same we saw for the cold water recovery. I'm going a little bit quick because I would like to show you the system working principle for these units. This is a standard, let me say, system we can propose for this kind of unit. But before arrive on this kind of solution, so with a heat pump, an intermediate plate heat exchanger, secondary pump, tanks, and three-way valve, we need to find out what are the system characteristics. And for system characteristics, for sure, we need to know the daily water consumption for the application in order to identify the peaks and the other daily consumption hour, let me say. In addition to this, we need also to know what are the temperature inside the circuit. So the tapping water temperature that is near the users, for example, the temperature the customer want to have inside the storage tank, the temperature of the cold feed water from the city water, of course the intermediate heat exchanger delta T, and the set point for the heat pump. So we need several information in order to size the right system for this application. Only to show you how the unit work, we start with the system with only cold water inside the tanks. In this case, there are no requests, and we are at the initial condition. Then the unit starts to charge the system. So unit treat cold water from the tanks and produce hot water to fill up the tanks with very hot water. So our idea is to have more or less one tank filled up for each hour. So after the first hour, we will be in this condition. After 2 hours, we will have this condition. After 3, this one. And after 4 hours, we have the system full with hot water ready to satisfy the peak. When there is a request from the users, you can see there is the on near the small shower. The unit start to use this hot water from the tanks to satisfy the users. So mixing the hot water with the city water, we can reach the tapping temperature and satisfy the users. This is the first, let me say, part of the functioning, because in this case, consumption from the users is one of the peaks. So it is higher than the heat pump capacity at that moment. So we start to use the water from the tanks. When it is needed, the heat pump start to work again. So when we are in a peak period, we can use at the same time hot water from the tank and also hot water from the heat pump in order to satisfy the system. And this could satisfy the peak. When the peak is over, we can still satisfy the users and fill up the tank at the same time. And when the system is completely full again, the unit will stop waiting for the next peak. That's all. Thank you very much for coming.